Welcome to Middle Class Matters Business News in English from Dr. CMA Allegation. Indian democratic backsliding in the world's largest democracy, that is India. Episode number 7. I examined this directly by creating a dummy variable at the polling station level called high BJP vote share that takes value 1 if the BJP vote share in the polling station is higher than the 95th percentile of the BJP vote share distribution in the entire sample. In these polling stations, BJP's vote share on average is 0.9. By construction, the average value of the dummy variable is 0.05. The dummy variable essentially flags polling stations with extreme outcomes in favor of BJP. Figure 4C and 4D plot the relationships for BJP ruled and non-BJP ruled states. The sample of PC's parliamentary constituencies is same as before, those with absolute BJP win margin within 0.16. We observe in figure 4C that in both constituencies won and lost by BJP, the average value of IBJP vote share is low in polling stations with turnout below 800. However, in larger turnout polling stations, the estimated relationships diverge. In constituencies won by BJP, the average likelihood of high BJP vote share increases sharply, going beyond 0.4, while the other graph remains flat. This is consistent with figure 4a. Moreover, there is no such pattern in the corresponding figure for non-BJP ruled states. The pattern in figure 4c is especially noteworthy given the fact that I only consider closely contested constituencies for the estimation. Hence, the rival party in these constituencies have received comparable vote share, which would make it less likely for BJP to get high vote shares in any polling station. Benford's law. I compute second digit distribution of absolute vote tallies across all candidates for each polling station to check departures from the Benford's law. Benford's law specifies the distribution of digits in different positions of naturally occurring numbers. Benford 1938, Raimi 1976. Manipulation of such numbers leads to a different distribution of digits, which allows analysts to detect the manipulation. Hill 1995. This method is used in a variety of contexts to detect fraud. Dickman 2007, Nigrani 2012, such as income tax receipts, financial transactions, as well as elections. In the context of election forensics, analysts usually focus on the distribution of second digits. However, treating a significant deviation from Benford's distribution in a given constituency as evidence of fraud in that constituency can lead to misleading conclusion, as researchers have shown that even in cases without fraud, empirical distributions of second digits can deviate from Benford's law. Shinako and Mac 2011. This can happen due to a myriad of reasons as discussed by McBurn 2011. I therefore do not test for deviations from Benford's distribution in each parliamentary constituency individually. I argue that presence or absence of patterns in deviations across parliamentary constituencies and polling stations is a better statistical test. I compute the erudition distance between the second digit distribution of the vote tallies of candidates in each polling station and the ideal second digit distribution specified by Benford's law. Figure 4e plots the Benford distance for each polling station against turnout for the same sample of PCs as figure 4c. Figure 4f plots it for the sample of PCs used in figure 4d. We observe that the Benford distance typically falls with larger turnout except for parliamentary constituencies won by BJP in BJP ruled states. In those parliamentary constituencies, the Benford distance falls initially with turnout but then rises for polling stations having turnout higher than 800. This is the same set of polling stations that exhibits irregular patterns as discussed above. This suggests that the extreme outcomes in favor of BJP observed in figure 4c may have resulted from some form of manipulation of vote tallies in that subset of polling stations. Shape of vote share density. Some recent works on deduction of electoral fraud examine the shape of density of vote share and turnout distributions using the booth or precinct level data. Rosanna's 2017, for example, tests for presence of excess mass at coarse vote shares using a resampled kernel density method. The method returns as output an estimated fraction of booths exhibiting fraudulent results. I applied this method to the polling station level data from Uttar Pradesh, UP, the only state for which turnout rate as well as BJP's vote share are available at polling stations, a requirement for the analysis. Also, a significant number of parliamentary constituencies from UP are in the list of parliamentary constituencies with narrow win margin. I find that in the full sample 0.13% booths are fraudulent. The share increases to 0.19% in parliamentary constituencies with BJP win margin less than 0.08 and won by BJP. The estimates are low but move in the direction that is indicative of fraud. Additionally, for comparisons, Rosna's 2017 analysis data from Russian elections in 2011 and 2012 and find estimates of 0.94 to 0.97%. Klimek 2012 argued that the density of vote share appropriately calculated and scaled exhibits high kurtosis in case of fraud and finds that Russian elections in 2011 and 2012 have kurtosis exceeding 10, while in other well-established democracies in Europe it is typically 5 or lower. In UP, the kurtosis is 29. Appendix figure A8 shows the density, which looks very similar in shape to those in Russian elections in 2011 and 2012, and unlike those in other countries. Interpretation. The patterns observed in figure 4a and 4c are consistent with both mechanisms. If the incumbent party was able to accurately predict the win margins in closely contested constituencies and wish to affect them, it might be optimal for the party to target the larger polling stations as they are fewer in numbers and mostly located in urban areas, making voters easily accessible for campaigning. This may result in high vote shares for the party in large turnout polling stations. Figure 4e and the analysis of the shape of BJP's vote share density, however, advance the manipulation hypothesis over precise control. 6. 5. data discrepancy and irregularities at polling stations. To further distinguish between manipulation and precise control and mechanisms, I utilize the fact that in closely contested parliamentary constituencies barely won by BJP, the EVM data discrepancy is significantly larger. If discrepancies in turnout data and high vote share of BJP in large polling stations are both driven by manipulation, then I should expect the two phenomena to be correlated. That is, irregular pattern in polling stations to be primarily driven by constituencies with larger data revisions. However, if precise control is the explanation, then such pattern should be similar irrespective of whether data revision was large or small. This is because in that scenario, larger data revision only reflect administrative errors during counting of votes, which should be uncorrelated with BJP's ability to exercise precise control at the time of elections. To test this hypothesis formally, I estimate the difference in discontinuity specification, where dP is the absolute discrepancy in turnout data in PCP measured in unit of 10,000 votes, and the rest are as defined before, measures the RDD estimate for relative BJP vote share in PCs without any turnout discrepancies, measures the differential discontinuity in the relative BJP vote share in parliamentary constituencies with additional discrepancy in 10,000 votes. Our coefficient of interest, therefore, is before discussing the results, I emphasize that even though the difference in discontinuity method is used to estimate heterogeneity in causal effect of some treatment, that is not the appropriate interpretation in this context. The estimation of equation 3 allows us to examine whether irregular outcomes in the polling stations are positively correlated with extent of turnout discrepancy in parliamentary constituencies barely won by the BJP. Table 7 reports the results for the full sample BJP ruled states and non-BJP ruled states. We find that estimate of or is negative and statistically significant in all columns. Parliamentary constituencies barely won by BJP with no data discrepancy exhibits a fall in relative BJP vote share. However, estimate of R2 is in column 1 is positive and statistically significant at 10%. Moreover, the magnitude of R2 is about 4 times larger than R1, suggesting that in parliamentary constituencies with discrepancies larger than 2,500 votes, the relative BJP vote share is higher in parliamentary constituencies won by BJP relative to parliamentary constituencies lost by BJP. Estimate of R2 is column 2 is 17 times larger than R1, while in column 3 it is twice as larger. The coefficient in both columns, however, are noisily estimated. We therefore have weak and suggestive evidence that turnout discrepancy at the level of parliamentary constituency is positively correlated with irregular outcomes at the polling stations in constituencies barely won by the BJP. Please like the video, subscribe to the channel. Please share it to as many people as possible so that the information about our democracy will be spread and democracy strengthens. Once we are aware, we will be able to take right decisions, how to vote and whom to vote. Thanks for watching.